Right now, 15 billion miles away, a small spacecraft the size of a car is drifting alone through the cosmic void, humanity's most distant ambassador, still whispering back to Earth after nearly half a century. This is Voyager 1, and it's on the loneliest journey ever taken. The year was 1977. Jimmy Carter had just become president. Star Wars dominated movie theaters, and NASA engineers realized they had stumbled upon a cosmic gift. For the first time in 176 years, the outer planets of our solar system were aligning in a rare configuration. Jupiter, Saturn, Uranus, and Neptune would line up like stepping stones across the darkness. This alignment meant a single spacecraft could visit all four gas giants using gravitational assists. Each planet would act like a cosmic slingshot, hurling the probe toward the next target. Without this alignment, visiting all four worlds would take decades and require massive rockets. With it, the journey could be completed in just 12 years. The mission was called the Grand Tour. Two identical spacecraft would launch just weeks apart. Voyager 2 lifted off first on August 20th, followed by Voyager 1 on September 5th. Despite launching second, Voyager 1 would arrive at Jupiter first, taking a faster trajectory. Each probe carried 11 scientific instruments packed into a frame weighing just 1,800 pounds. Golden records were bolted to their sides, containing sounds and images from Earth. But their real purpose was exploration. These robots would become our eyes and ears in the outer solar system. The first destination was Jupiter, the king of planets. When Voyager 1 arrived in March 1979, it revolutionized our understanding of the gas giant. The probe discovered that Jupiter's Great Red Spot was actually a massive storm larger than Earth itself. It found active volcanoes on Jupiter's moon Io, the first discovered beyond Earth. Lightning bolts 10,000 times more powerful than terrestrial lightning crackled through Jupiter's atmosphere. But Jupiter was just the beginning. The real spectacle awaited at Saturn. When Voyager 1 reached the ringed planet in November 1980, it sent back images that left scientists speechless. Saturn's rings weren't simple bands of ice and rock. They were intricate structures with thousands of individual ringlets, braided together by the gravitational dance of tiny shepherd moons. Here, mission planners faced a crucial decision. They could send Voyager 1 onward to Uranus and Neptune, following its twin, or they could redirect it for a close encounter with Saturn's mysterious moon Titan. Titan was shrouded in thick orange haze. Scientists suspected it might harbor organic chemistry, perhaps even primitive life. They chose Titan. Voyager 1 dove close to the enigmatic moon, peering through its atmosphere with radar and infrared instruments. The probe discovered a world with lakes of liquid methane and ethane, organic compounds raining from the sky. It was like a frozen version of early Earth. But this choice came with a price. The close encounter with Titan bent Voyager 1's trajectory upward, out of the plane of the solar system. It would never reach Uranus or Neptune. Instead, it was heading towards something far more profound. The edge of everything we call home. Meanwhile, Voyager 2 continued the grand tour alone. It visited Uranus in 1986, revealing a planet tipped on its side with faint rings and strange magnetic fields. At Neptune in 1989, it found supersonic winds and a great dark spot rivaling Jupiter's famous storm. With Neptune's flyby complete, both Voyagers had finished their primary missions, but their greatest discoveries lay ahead. As Voyager 1 raced toward the outer boundary of our solar system, it was entering uncharted territory. The Sun creates a massive bubble around our solar system called the heliosphere. Solar wind, a stream of charged particles from our star, pushes outward at 1,000,000 miles per hour. But eventually this wind meets resistance from interstellar space. The boundary between these regions is called the heliopause. No human-made object had ever crossed this frontier. Scientists weren't even sure exactly where it was located. Estimates ranged from 90 to 120 times Earth's distance from the Sun. Voyager 1 would have to travel for decades to reach it, all while its power slowly faded. The spacecraft runs on radioisotope thermoelectric generators, nuclear batteries that convert heat from decaying plutonium into electricity. When Voyager launched, these generators produced 470 watts of power. By 2023, that had dropped to just 249 watts. Every year, Voyager loses about 4 watts more. As power declined, NASA began shutting down instruments one by one. The cameras went dark in 1990. Plasma wave detectors were turned off to save energy. By 2012, only 4 instruments remained active, but those 4 were enough to detect something extraordinary. On August 25, 2012, Voyager 1's instruments registered a sudden change. The density of charged particles around the spacecraft dropped dramatically. At the same time, cosmic rays from deep space increased. The probe's magnetometer detected a shift in magnetic field direction. After 35 years and 11 billion miles, Voyager 1 had crossed the heliopause. It was now in interstellar space. The achievement was bittersweet. Humanity had reached the stars, but our messenger was now so far away that radio signals took over 17 hours to reach Earth. By the time NASA received confirmation of the crossing, Voyager 1 was already millions of miles deeper into the void. 6 years later, Voyager 2 followed its twin across the boundary. But its crossing revealed something unexpected. The 2 probes had exited the heliosphere at different locations, and the boundary conditions were different. This suggested the heliopause isn't a smooth sphere, but a complex, shifting frontier influenced by interstellar currents. Today, both Voyagers continue racing through interstellar space. Voyager 1 travels at 38,000 miles per hour relative to the Sun. Even at this incredible speed, it would take 73,000 years to reach the nearest star, Proxima Centauri. But Voyager isn't headed toward Proxima. It's aimed toward the constellation Ophiuchus, where it will pass within 2 light-years of a star called AC plus 793888 in about 40,000 years. The probe's most profound moment came in 1990, just before its cameras were shut down forever. Carl Sagan convinced NASA to turn Voyager 1 around for one final photograph of home. From 3.7 billion miles away, Earth appeared as a tiny blue dot suspended in a sunbeam. The image became known as the pale blue dot, and Sagan's reflection on it remains one of the most moving meditations on our place in the cosmos. "That's here," Sagan wrote. "That's home. That's us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives on a mote of dust suspended in a sunbeam." The pale blue dot image reminded us that despite our differences, we all share this tiny world lost in the cosmic dark. And now, bolted to each Voyager probe, golden records carry a message from that pale blue dot to whoever might find them in the far future. The records contain 115 images showing the diversity of life on Earth, mathematical definitions and physical units, greetings in 55 languages, sounds of wind, rain, and surf, animal calls from whales, birds, and crickets, music ranging from Bach to Chuck Berry, the cry of a newborn baby, a mother's kiss. But the records also carry something more abstract. They represent hope. Hope that intelligence exists elsewhere in the universe. Hope that whoever finds these artifacts will understand what they represent. Hope that humanity's story won't end with us. That hope is being tested now. In April 2023, Voyager 1 experienced a serious malfunction. Its main radio transmitter failed, forcing the probe to switch to a backup system that hadn't been used since 1981. The backup transmitter is weaker and uses more power. Engineers estimate it reduces the mission's remaining lifespan by several years. Communication with Voyager is becoming increasingly difficult. The probe's signal is incredibly weak when it reaches Earth, just 20 billion times weaker than a watch battery. NASA's Deep Space Network uses massive 230-foot antennas to capture these whispers from the void, but even these giants struggle as Voyager grows more distant. Current projections suggest Voyager 1 will fall silent sometime between 2025 and 2030. One by one, its remaining instruments will shut down as power fades. The plasma wave detector will go first, followed by the magnetometer and cosmic ray detector. Finally, even the backup transmitter will lack the energy to reach across the growing gulf between worlds. But silence won't mean death. Voyager 1 will continue its eternal journey through the galaxy long after its voice fades. The spacecraft is built to last. Its aluminum structure can withstand the harsh environment of interstellar space for millions of years. The golden record, protected by its aluminum cover, could survive for billions of years. In 5 billion years, when our sun swells into a red giant and consumes the Earth, Voyager will still be out there. When the sun finally dies, leaving behind a cold white dwarf, the probe will continue its voyage through a galaxy of dying stars. When the last stars burn out and the universe enters its final age of darkness, Voyager may still be drifting through the cosmic night. This is perhaps the most profound aspect of the Voyager mission. We have created something truly eternal. Long after our species is gone, long after our planet is consumed by stellar fire, these two small robots will carry a piece of humanity through the stars. They are our most lasting monuments, more permanent than the pyramids, more enduring than any work of art. In a universe of unimaginable loneliness, they ensure we won't be completely forgotten. Right now, as you listen to these words, Voyager 1 is racing through interstellar space at 11 miles per second. It's colder than Antarctica, more isolated than any place on Earth. Its nuclear heart beats steadily, powering instruments that taste the interstellar wind and measure cosmic rays from distant supernovas. Somewhere in the galaxy, perhaps around a distant star, other beings might be listening to their own cosmic messengers. Maybe they too have launched their own Voyagers into the dark, carrying their own golden records, their own hopes and dreams. Until that day of contact, Voyager remains our ambassador to the cosmos, a testament to human curiosity, ingenuity, and our deep need to explore. It represents the best of what we can achieve when we look beyond our small world and dare to touch the infinite. The loneliest journey ever taken continues, and in that lonely journey, we find something beautiful. We find ourselves.